Hey everybody, it's Mr. Cubby here, and you should have done the Desmos activity during class where you kind of were exploring how transformations work, and you may have talked about some of this in your class debrief, or you may have not. So I'm kind of just going to recap it, kind of what was the important information that you were supposed to get out of that activity about how transformations work, okay? This is the most important topic from this first unit. We will come back to this in most of the chapters in this class. Okay, so please pay very close attention. When we're talking about transformations, we're talking about how you take a function and you transform it. Think about transformers. They change shape. How do you transform a function? How do you change a function? There are three main ways you can change a function. You can shift it, you can dilate it, or you can reflect it. Okay, you can do all three of these things either horizontally or vertically. Okay, let's start with the vertical stuff. If you want to shift a graph vertically, you're going to be shifting it up or down. And the way to do that is to take your function and add a constant on the outside. This works just like you think it works. Okay, that's my phrase that I always think about when I think about vertical transformations in general. Vertical transformations work like you think they work. In other words, how do you move a graph up 2? You put a +2 at the end. How do you move a graph down 7? You put a -7 at the end. Okay? So they work like you think they work. So a plus k, we'll move it up k. You want to move it down, then make the k negative. Actually, I really shouldn't say that, up k. If it's positive, it'll be up. If it's negative, it's down. Dilations are another type of transformation. Okay. Actually, I should say one more thing about shifting. There is a fancy word for shifting. It is to translate. Okay. So you could say shift up to, or you could say translate up to. Don't say shift to, because you need to say up or down. Okay, so that is important. Another type of transformation is a dilation. Okay, so what does dilate mean? Well, think about when you go to the eye doctor and you get your eyes dilated, maybe. It means they stretch. That's what a dilation is. I would like you to use the word dilation. That is the fancy word. Okay, so translate's a fancy word, but you can use shift. Dilate's the fancy word. Please use dilate. How do you do that? You multiply your function by something. Okay, again, this works the way you think it works. If you want to do a vertical dilation, if you want to stretch it vertically and make it twice as tall, well, you put a 2 on the outside. If you want to make it half as tall, you put a half on the outside. Okay. Multiplying results in a stretch and a dilation. Adding results in a shift. Okay. Last thing is a reflection. And if it's a vertical reflection, so let's say you got a picture of Benny, classic picture, and you want to flip it vertically. Well, if you flip something vertically, you're actually flipping it like this, right? There, I flipped it vertically. If you flip it vertically, you're actually flipping over a horizontal line. And if you think about a graph, what do you call that horizontal line here? You call that the x-axis. Okay, so a vertical reflection is actually a reflection over the x-axis. And how do you do that? You put a negative. Okay, most important thing, pay attention right now, most important thing, all of the vertical transformations are on the outside of the function, on the outside of the parentheses. I will say that again. All of the vertical transformations are on the outside of the parentheses. If you add on the outside, it's a vertical translation. If you multiply on the outside, it's a vertical dilation. If you put a negative on the outside, it's a vertical reflection. In other words, a reflection over the x-axis. Okay, so if you do stuff outside, it's vertical, and they work like you think they work. If you can have that phrase in your head, you're going to be all good. Okay. The reason that I have those phrases in my mind is because horizontal is basically the complete opposite of that. Okay. So vertical transformations work like you think they work. Horizontal transformations, they work backwards. Okay? So, oops, sorry. So if you want to shift it, okay, and you're still going to use addition, but that addition is going to be on the inside of the parentheses. And I'm going to use, doesn't really matter what letters we use here. I mean, if you really want to get technical, a lot of times you see like an A used here, but it really doesn't matter what you use. If you want to have a translation horizontally, you're going to have addition still, but notice that this addition is on the inside of the parentheses. So addition on the inside is a horizontal shift, left or right. Addition on the outside is a vertical shift, up or down. Back to the work backwards thing. These transformations work backwards. Okay? Meaning if you have a +3 on the inside, for instance, you would think that would mean right 3, but it actually means left 3. Because it works backwards. So +3, you would think horizontally would be the right, but it's actually the left. Minus, you would think would be the left, but it's actually just right, because they work backwards. Same with the dilations. Okay, again, we're talking about on the inside here. You're going to have multiplication again for a dilation, for a stretch, but it's going to be on the inside. Again, if you had multiplying by 2, you think it would make it twice as wide. You think it would stretch it horizontally and make it twice as wide, but it actually makes it half as wide. Okay, this one's a little tricky. So the factor you are dilating by is the reciprocal of whatever that number is. Okay, so if you have f of 2x, doesn't make it, it's not a horizontal dilation by a factor of 2, it's a horizontal dilation by a factor of 1 over 2. Okay, it works backwards. It's not twice as wide, it's half as wide. Okay, same with, last thing is the reflection, and here you're going to have the negative not on the outside, but on the inside. And again, if you are reflecting now horizontally, if you think of a little picture, I don't have another picture of Benny, so I'll just draw a picture. Easy there. There's a picture of Benny. If you reflect it horizontally and you flip it over here, you're actually reflecting over this line, which is called the y-axis. So a negative on the inside is a horizontal flip. In other words, it's a reflection over the y-axis. Okay? So if I was going to give my 30-second summary, I'll do it one more time because this is really important. Addition on the outside, everything on the outside is a vertical transformation. Addition shifts it up and down, multiplication dilates it, and a negative reflects it vertically, which is a reflection over the x-axis. On the outside is vertical transformations, and they work like you think they work. +3 moves it up 3, times 2 makes it twice as tall. Horizontal transformations are all on the inside of the parentheses, and they work backwards. +5 on the inside doesn't move it right 5, it actually moves it left 5. Multiplying by 3 on the inside doesn't make it 3 times as wide, it makes it 1/3 as wide, the reciprocal of whatever that is. Okay, they work backwards. Okay, now it's just time to dive into some problems. Okay, all it wants you to do is, given an original function f of x, describe the transformations applied. I'll do a couple of these with you because I do want you to use the correct vocab. That's very important. And then I'll let you do the rest. Okay, so here's my thought process. It's addition, so it's a translation, it's a shift. It's addition on the inside, so it's a horizontal translation. Okay, now I just have to decide, is it right 3 or left 3? Well, it's horizontal, so it works backwards. So a +3 is actually a translation. Left 3. Okay, let's do this one. I have a +3, so it's going to be a shift, a translation. It's on the outside, so it's going to be a vertical translation. It's +3. Vertical transformations work normal, so +3 is just up 3. And I should say shift or translate up 3. Okay. I'll do 2 more with you. Ooh, I got 2 things going on here. I got a +1 on the inside, and I got a multiplication by 2 on the outside. Both of those things are going to do something. Like both of the additions of those numbers are going to change the graph. Let's look at the inside one first. +1 on the inside is going to be a translation. It's on the inside, so it's going to be horizontal, and it's backwards. So instead of being right with a plus, it's going to be left. So it's a translation, left 1. Multiplication is dilation. It's on the outside, so it's going to be a vertical dilation. And it's vertical on the outside, so it works normal. So it's a vertical dilation by a factor of 2. I'll say that again. A vertical dilation by a factor of 2. It's important that you use that phrasing because it's a stretch. You're multiplying it. So it's kind of like how you say, you don't say make something 2 bigger. You say make it twice as big. You say, you stretch something by a factor of 2. You don't stretch something 2. Okay, you need that phrase by a factor. Let's do 7, and then I'll leave you to do the rest. Okay, doesn't matter which one you do first now. We'll talk more about that in the next video. So if you're wondering, like, why did you pick that first and that second? Good question, good question. We'll get there. That's the next video. Let's do this first. I got a +1. It's on the outside, so it's vertical. It's a vertical transformation, so it works normal, and a +1, just a translation, up 1. Inside the parentheses is horizontal. It's multiplication, so it's going to be a stretch. It's going to be a dilation. Ooh, but it's horizontal, so it works backwards. So it's not a horizontal dilation by a factor of 2. That would be normal. It's not twice as wide. It's a horizontal dilation by a factor of 1/2. The reciprocal of whatever that is. What's the opposite of times 2? Times 1/2 divided by 2. Okay. All right. Why don't you pause and give the rest of these a try? Give all the rest of these up until 10 a try. Thank you. Okay, I'm not really going to talk about these, but here are the answers. Again, we are not paying attention right now to the order. So if you had translate down 3 first and then translate left 2 for second, like for instance for number 5, that doesn't matter right now. It is important that you state for the dilations whether it's horizontal or vertical. So for this one, you need to say a vertical dilation by a factor of 1/2. It matters. Okay. For 11 through 16, it's just flipping the question around. It's saying, hey, I got a function f of x. Write a new function which does these transformations. Okay. So now we're just writing the function instead of like reading the transformations from the function. We have the transformations and we're trying to create the functions. Okay. So I got f of x. If I want to do a vertical shift up 2, I'm going to add 2 outside of the parentheses. If I want it to do a horizontal shift, horizontal translation, right 5, I'm going to have something inside the parentheses. And if I want it right, you would think it would be a +5, but the horizontal stuff works backwards. So inside the parentheses, I'm actually going to have a -5. Okay. And it'd be nice if I wrote like y equals that. Here's my new function. Or I could write like g of x. All right, let's do 12 together, and then I'll let you try the rest. A vertical dilation, a vertical stretch, so I'm going to be multiplying. It's vertical, so it's going to be on the outside, and it's vertical, so it's going to work normal. So how do I do a vertical dilation by a factor of 4? Well, I just multiply the outside by 4. Easy enough. Okay, give 13 through 16 a try, and I'll show you my answers. Okay, here's what I got here. A couple things that are a little tricky for people. For the reflection, so it's a reflection over the y-axis. Think about it vertically. If it's a reflecting over the y-axis, so that's a horizontal flip. You're flipping like that, meaning it should be a negative on the inside of the parentheses. Okay, so that's why I have that negative in there. Then a vertical shift up 3 is +3. For this one, it's a horizontal dilation by a factor of 8, so I'm going to be multiplying by 8 on the inside. But wait, horizontal stuff works backwards. So I'm not going to be multiplying by 8 on the inside. I'm going to be dividing by 8 on the inside. In other words, multiplying by 1/8. Please acknowledge that multiplying by 1/8 and dividing by 8 are the same thing. Thank you. Okay, and there's 15 and 16. Okay. Last page here. I just want to show you one other type of problem you could see involving transformations. And that is, instead of thinking about it strictly from a function notation perspective, we could think about it graphically. Okay, so you could have a graph of f of x, and we could try and transform it, figure out what the transformation did, and then graph that new graph. Okay, so first, let's just identify the transformations. Let's just do these first two, since that's like the thing we've been doing. So what would this new graph look like? We'll have -2 on the inside, so it'd be a horizontal shift. Left 2, oh wait, no, it's backwards. If it's horizontal, so it'd actually be right 2. Okay, for this one, a negative on the inside is going to be a horizontal flip. A horizontal reflection is over the y-axis. So I'm going to reflect over the y-axis. And then a +4 is going to move it up 4. Okay. Now, how do you actually do this graphically? There's lots of ways to do this. You could just take this graph and try and draw it right 2. That's totally fine. It's going to get more complicated when we start having more transformations. So what a lot of kids like to do is they like to make a little table. So they take these points, these coordinates, and they make a little table. So they come over here and they make a little XY table, and they say, here were the original points. Okay. And they say, I'm going to apply this transformation to that table. Now, I didn't say this before because I think you know it, but we can go back and add it to our chart if you want. Horizontal transformations change which coordinate? The X or the Y? Use your brain for a second. Horizontal stuff. Oh, like horizontal stuff to the X. So this right 2 is going to change only the X coordinates. What's it going to do to them? Well, it's going to make them 2 bigger. Okay, so if you want to go back to your table here, this important table, something that it might be good to add is that vertical transformations only affect your Y coordinates. If you're thinking about it from a graphical perspective. And horizontal transformations, they only affect your X coordinates. Okay, so going back here, I'm just going to take my table and I'm going to make my X coordinates 2 bigger. And I'm literally just going to redraw the table. Y coordinates, unaffected. X coordinates, 2 bigger. Now what? Graph those points. -1, 4. 3, -1. 4, 3. 6, 3. Connect them. This graph, looks like this graph moved right 2. I know the graphs are a little bit different sizes because of the actual axes we drew, but the graphs look the same. This one's just moved right 2 of the original one. Okay. Again, you don't have to do this table thing, but it's going to help you. Why don't you try and do that with 18 real quick? Go ahead, give it a try. Okay, so that's what I got here. Again, I started with the same original function. Here I had 1 horizontal transformation and 1 vertical transformation. The horizontal transformation affected the X coordinates. Well, what does a reflection do? It just changes the X coordinates from positive to negative, negative to positive. It makes them the opposite. What does the up 4 do? Well, it takes your Y coordinates and it makes them 4 more. Okay, so one of the transformations changes the X coordinates, the other one changes the Y. Some people like to do 2 tables, like 3 tables, I guess. Like they do one where they make that change the X's and another one where they make the Y's. I just kind of did it all in one jump. Okay, and if you look at this graph and you look at the original, this graph is clearly reflected over the y-axis. You know, it's like not, it doesn't go down, up, over, it goes over, down, up. And it's moved up much higher. See how this one goes across the x-axis here, and this one's way up higher. It doesn't go here. Okay. All right, I'm going to leave these bottom two and just stop right there. We'll do practice with this transformation stuff. This is going to be really, 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 really important in this class because these transformations work for any type of function. So we'll be graphing logarithms and exponentials and sine graphs and secant graphs and parabolas and polynomials. And we'll be coming back to this idea of shifting those graphs right 2 and shifting those graphs up 4 and dilating them by a factor of a half horizontal. So those ideas are going to keep coming back up. Okay, cool. That concludes this video. Thanks for watching, guys.